Alright, now sorry about the slow response. Draw the Bohr-Rutherford diagram and Lewis structure for nitrogen 15. So I look at my periodic table and I can see that nitrogen has 7 for its atomic number, so I know its protons equals 7. And if I take 7 and subtract from 15, I'm going to get my neutrons to equal 8. First orbit's got 1, 2, 3, 4, 5, 6, 7 outer electrons. Total electrons. So that's the Bohr-Rutherford diagram. For the Lewis structure, you can write the letter N and go 1, 2, 3, 4, 5. These electrons right here reflect the outermost orbit, and the letter N would indicate that this protons equals 7. If you wanted to be a little bit more specific, you could also add in that its mass number was 15. So you could write that right there. That's going a little bit overboard. I honestly don't think you'd have to go that far, but that's fine for right now. So in the next part of the question, it asks you to draw a Bohr-Rutherford diagram, a Lewis structure of the ion that would most likely form. So the Bohr-Rutherford really is pretty straightforward. I'm just using what I had gotten in the last question. 2 on the first orbit, 1, 2, 3, 4, 5 on the next orbit. So you think to yourself, what's going to happen? Well, most likely it's going to gain 3 electrons, forming a 3 negative charge. So there's a Bohr-Rutherford. And for the Lewis structure, I would have N, and I'd have 1, 2, 3, 4, 5. And then draw square brackets for 3 negative. Perfect. Show electron transfers using arrows. So these were gained. This was gained, that was gained, and that was gained. And write the formula for potassium nitride. Well, you could assume that potassium gave up these electrons, and the potassium nitride formula would be K3N. Why'd I go with a K first? Well, we always go metals first. Draw a diagram of the molecule that would form if nitrogen bonded to itself. So I'll do that next. So if nitrogen bonded to itself, I know that nitrogen's got 5 other electrons. So I'm going to just draw it like this. I'm going to say nitrogen. I'm just going to move those outer electrons around a bit. And so what would happen is nitrogen would have to share, and so it would share, share, and share. So you can kind of get the idea of how that sharing happens. So that would be the rough work, and then the cleaned up version would be N, 1, 2, 3, N, dot, 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 dot. And you can kind of get the idea now that this nitrogen atom has 1, 2, 3, 4, 5, 6, 7, 8 shared total electrons in its outer orbit. This nitrogen right here has got 1, 2, 3, 4, 5, 6, 7, 8, and these lines indicate the sharing or the bond that happens between them. What word is describing an element that exists with 2 atoms per molecule, and if they're identical atoms, we would call it diatomic. Alright. For number 3, you ask about the Lewis structure for formaldehyde. So I know that formaldehyde would be carbon, so 1, 2, 3, 4. Carbon 1, 2, 3, 4, and carbon would bond like this. And then I know, too many carbons, sorry about that. So we've got 1, 2, 3, 4 for carbon. It has 2 hydrogens that it would share with. And then oxygen over here has got 1, 2, 3, 4, 5, 6, and so this kind of idea would happen. So there's my rough work, and cleaned up it'd look like this. And you can kind of get the idea now that hydrogen's got 1, 2 outer electrons, so it has a full orbit. Hydrogen has 1, 2 electrons due to sharing, so it has a full outer orbit. Carbon's got its 1, 2, 3, 4 original, 5, 6, 7, 8, now that's shared. Oxygen's got its 1, 2, 3, 4, 5, 6 original, 7, 8 shared. And so there's formaldehyde. For the peroxide ion, it's here. Peroxide ion, what would likely happen is you'd have oxygen bonding with oxygen. So that's a share right there between these two electrons. Let's say that something like sodium, there we go, something like sodium comes along, and sodium gives up its one outer electron, so that electron goes over there. And this sodium over here comes along and it gives up its one outer electron to here. The whole molecule now becomes 2 negative, and that's how we get the peroxide ion. This whole thing would be the peroxide ion. That's why we write it as O2, because there's 2 oxygen atoms, and because the gain of 2 electrons, it's 2 negative. And our formula here would be Na2O2. So there's peroxide for you. I'm just looking at what else your email had asked. 2, 3, and 4A. So just give me a second to pull that up. I just need to get that review back up again. Sorry about that. 4A. Draw 5 water molecules positioned to maximize intermolecular bonding. Draw the covalent bonds with a dash and intermolecular bonds with a. Okay. So, if I had water, it'd be like this. And we know from earlier that it has an overall molecule dipole like this. So this would be the slightly positive side of the molecule, and this would be the slightly negative side of the molecule. And I hope that kind of makes sense. So I'm going to get kind of that writing to go away. I'll see if it will go away. It won't go away, so let's see if I can erase it away. There we go. So we have some of the writing to go away now. So what would happen is, because this end of the molecule is slightly negative and this side of the molecule is slightly positive, I've drawn my bonds within the molecule, or the intra molecular bondings, with a straight line or a dash, and then I'm going to draw the intermolecular bonding, or the attraction between the molecule, as a dotted line, so you can kind of get the idea there. And then you could have another water molecule come along, and it would look like this, and there would be some bonding that way, and I'll let you think about how to maximize it, but you can kind of start to get the idea of what's going on here. So again, we could go with O, H, H, and there's my intermolecular attraction or bond that would form.